Let's discuss the other topic that is related to the right-hand side of a variable assignment, uh, such as x equals to 1 to 3. So we are talking about the value part of it, right? So the 1, 2, 3 part of it. So here, value constants and literals, what are they? When we hear programmer discussion that talks about that constant and this constant versus this literal, and when we look at constants that they mention, they are typically referring to a variable name. So that can sound very confusing to a beginner because why are you talking about constants when you are referring to the variable name? And if it's variable, that means we are changing it. It's varying. That's why it's called variable. Why are we calling it a constant? So this has got to do with two things. The little bit of I'm trying to use the word abuse, but try not to use the word abuse as well, because we use it so easily, so naturally for programmers that we just basically refer to the variable that we actively, consciously not try to change it after being assigned the initial value. We call that variable a constant. So we can basically be staring at a variable name and still call it a constant because statements like this that usually run at the start of a program, of a Python script or a program, are basically going to be held in that particular fixed value throughout the lifespan of the program. We're not going to change it. We consciously do not change it. And because of the way that we constructed the usage discipline of this variable, such as expansion plan activated true, that we don't intend to change it, then it is basically going to be used more or less like a constant. But we don't want to always use true because true can mean many things. But when we say expansion plan activated or not, true, activated, right? So depending on the settings, it can be true, can be false. But this variable name is very suggestive, very descriptive, very clear in the meaning. So through our disciplined avoidance of changing the value, we have made this variable a constant or holding a constant value throughout the lifespan of our program. So in short, we are saying this is a constant. So use the constant expansion plan activated will be some sort of a description you commonly read from Googling sample Python code. All right, so just use the constant x underscore OK, something we have seen earlier on. That's the constant defined in the OS module, when actually it is a variable name defined under the OS module. But in the descriptions, you will see, oh, just use os.x underscore OK constant, right? So the word constant in programming sense actually refers to a variable that holds a fixed value, and we practice the discipline of not going to change it, although it's changeable, but we are not going to change it throughout the lifespan of our program. Then we call that variable a constant. Now, what we are confused with as a beginner is that the fixed value, such as true itself, such as the string hi, welcome to our store, this text or this string or this value 1, 2, 3, 4, 5, our beginning bank account, for example, this is called a literal. This is not what we, in layman's term, call a constant. It is constant for sure. It's not going to change. And it is also a value because we understand that in Python, all these are values, are object values. But more importantly, when we specifically refer to explicitly typed out values like these, they are called literals. I mean, it's literally there, literals. So true is a literal, false is a literal, 1, 2, 3, 4, 5 is a literal. The string is a literal of type string. And true, false, they are literals of type Boolean, BOOL. 1, 2, 3, 4, 5 is a literal of type int, and 2.55 is a literal of type float. Notice that the literals themselves are also manifest type literals. That means when we look at it, we can tell its type immediately. Isn't that true? Because when we spell out true, we know its type is Boolean, B-O-O-L. It's not going to be a 1, but pretending it to be true. And when we put false, we know it's of type Boolean. It's not an integer type, but happens to be containing the value that 0 that means false. Not like that. Okay, so 1, 2, 3, 4, 5, because it lacks decimal place, we know immediately it's int. It cannot be any other type. When you do have the dot there, even just 2 dot, it is not integer 2, but a floating point 2. So here we definitely have a floating point value called 2.55. And this piece of programming typing here, 2.55, is a literal. So here is another literal, which means it's a fixed value, but of type string. And this is another fixed literal of type string, just equivalently starting and ending with a single quote instead of a double quote. Okay, let's run this, which is not very complicated, but just practicing our sense of using clear variable names and calling them constants, because we are not going to change the values. So Brave, welcome to our store. And street name is Brave, and like this, right? And then we can use the literal, the F string literal, which allows us to format a long string. So the triple quote is for us to store long strings, which include the return new line at the end of the string. What we see in the programming space is what we get in the runtime space. That's what the triple quote gives us. Right? So in this case, we not only have a triple quote like this, we also have a formatted string triple quote. So the difference between them is that without the formatted string, we will literally see what we type. What we type is what we see, like this. Okay, so if we do this without the formatting and run it, first of all these are, oh, I should have included the curly bracket, but as you can see in other examples of the curly brackets, nothing gets changed. We have assigned values. These are where, so the right way to say it is we have assigned these right-hand side literals, right, and they are manifest type literals because we can tell their data type from looking at it, just looking at it. Sometimes not, but this is okay. So here we are assigning these literals to these variables, and because we don't intend to change these variables values, we're going to let them hold on to the initialized values. We basically call them the constants, even though now we understand programmer's idea of constant is a variable holding a fixed literal. Okay, good. So when we print this out, it sort of didn't get what we want because we didn't ask Python to look inside the string. All right, this triple quote buys us this a nice feature of what you type is what you see in the runtime space. However, without the F prefix, Python didn't peep into the content. It just dumps out whatever you put in. With the F prefix, Python starts to look inside, and whenever it sees a curly bracket, all right, it says, oh, you want the value of the variable name expansion plan activated, is it? I'm going to erase this. I'm going to look up the variable name expansion plan activated, which is true, and I'm going to put the value directly in place of everything, including the curly brackets. So let's run it again. And you see that, oh, great, this is exactly what we want, because we want to see what's the value of expansion plan. Give me the value. And you say that to Python by inserting, first of all, a curly brackets and putting the variable name inside. And of course, you can do a bit of a basic arithmetic inside. All expressions in Python are available, but you don't want it to be super complicated. You don't want it to have, you know, very lengthy calculations inside. Simple basic adjustments are okay, and it's not confusing, right? And when we look at it, The idea is simplicity and clarity. We don't want it to be too bogged down by the calculations. You might want to calculate outside and store it in a temporary variable and then point it. The whole point of this formatting is allowing us to see the global design of the output. So we now know it's going to be 6 lines, and each will have an equal sign equal to the value. Yeah, because it's so easy to see the overall design. So the idea is not to pack all the calculations inside the curly brackets, but to take advantage of what you see is what you get to design the overall presentation to the user. Okay, so this part we covered what is constant and what is literal. Hopefully the confusion will not continue. And there are some more examples in the slides that you can read about. Yeah. Next, let's look at a bit of interesting literals, mostly to do with strings. Strings are very important because a program is essentially a string. So when you are asking Python to run your program, Python essentially reads in character by character, so which is a string, right? So string is very important. Now, we have already seen a demonstration of the multi-line string like this, right? So a multi-line string allows us to have very, very long string, including returns, right? Including new lines like this. So we can put this in here. And when we are designing a mailing label, it's really quite sensible to try to use the multi-line string, because it allows us to do what you see is what you get. So mailing label by this or this. So mailing label is triple quote of this and then ending with triple quote. Error string is triple quote. Oh, just as a change, we say that this is for quiz mark, right? Like this, ending with triple quote. So if you start with triple double quote, you end with triple double quote. If you start with triple single quote, you end with triple single quote. All right. And then we print mailing label. All right. Just trying to see how to get back the original program here.